So our next plenary session is going to be Revolutionizing the Future of Retail, the Rise of Automation. Tom Bianculli, who is the Chief Technology Officer at Zebra Technologies, is going to be our next guest. Tom, are you here? Perfect. Please welcome him on stage.
Hey, good morning, everybody. Great to be here. I want to share a little bit of perspective and zoom out a little bit because so many of us are inundated with various types of technologies, and some of us are tracking a lot of those technologies, whether it's machine learning, it's artificial intelligence, it's wearable computing, data analytics, cloud, 3D printing, additive manufacturing, generative AI. There's all this technology out there. But what's often overlooked is that all of those technologies are in service of one underlying dynamic. And that's to push the production and provision of value ever closer to the point of demand. So all of these technologies are digital technologies, and what they're doing is enabling us to push that production of value ever closer to the moment of demand in time and space. This is a concept called proximity, and Professor Robert Wolcott from Kellogg at Northwestern University has said that this is one of the most transformative and powerful forces reshaping markets, the ability to do this. So when you're looking at the technologies, even when you're looking at AI, you're looking at real-time sensing, IoT, don't think about the technology. Think about how that technology could be used to push that production and provision of value ever closer to the point of demand. And what do I mean by that? Well, just think about your own experiences. Think about ordering an Uber on a street corner. You press that button on the app, and that service is being delivered in your moment of need, right? You put rooftop solar on your house, and the energy production is being delivered to that house at that time and space in the moment of need. You place an order online, and you have it delivered to your doorstep within sometimes 30 minutes or an hour. So you're getting more and more selection of product delivered and closer to zero time. And that's probably one of the most powerful and transformative forces that we're going to be dealing with. And so if you believe that, what needs to be true? Well, innovation is going to shift from the core. Think about innovation from an IT perspective with warehouse management systems or inventory management systems, transportation management systems. Those are all systems of record. And innovation is shifting from those systems of record to the right-hand side of this chart is what we call systems of reality. And you heard it actually from Tim from Sam's Club when he spoke about the robots in the store outfitted with computer vision and scanning and RFID technology. What was that robot doing as it traversed the store? It was collecting in real time that information about the shelf. It was creating a system of reality as it traversed the store. No longer could Sam's Club say, well, I think I know what's on the shelf or what's on the rack. They deployed technology to actually see, literally see what's on the shelf and on the rack, and do that multiple times per day, continuously, to create that system of reality. And so, what's the outcome of that? It's that planning and execution systems are collapsing on top of one another. So think about the way you might traditionally run your operations, whether it's people planning, it's capital asset planning, it's inventory planning. You create a plan, then you execute that plan, and then you recast the new plan. But shift your thinking a little bit. If we're in an on-demand world, if we're entering a future in which the production and provision of value is going to be pushed ever closer to the moment of need, what does it mean to have a plan? A plan is for those that are going to lose, actually. Because if you're planning and then executing, you're going to try to just spin that cycle faster and faster, right? If I've got to deliver in 60 minutes based on an order you placed online, a minute into my plan, it's already expired, right? Because a new order has come in, and I have to now react with my supply chain. I have to react with my planning and my operations differently. So we've got to move towards streaming operations. So if you're operating in an on-demand way, you got to be sensing, assessing, responding. That requires digital precision. What's an example of digital precision? The robot in the store. RFID monitoring what's happening from an inventory point of view. Telematics that are on all of the fleet of vehicles that are delivering goods across a whole host of stores or to distribution centers, and being able to understand where every product is in that supply chain at every moment in time. That's digital precision, and that digital precision is driving physical velocity. The better we can measure that capability, the more we can deliver an on-demand experience, which means things get delivered faster, that production of value gets pushed ever closer to the point of demand, and then the cycle continues, right? That physical velocity drives the need for more digital precision, and so on and so forth. So if you're not thinking this way, if you're not embracing the on-demand world and thinking how you can deliver more selection in closer and closer to zero time to your customers, you're going to miss on those expectations. Hendrith Smith, the CEO at Mayflower Plymouth, took this kind of to the limit. And he made this analogy to what happens in nature, right? If you play out what I was just describing, what is a warehouse? Well, a warehouse is a place you store things. But if you think about it delivering in an on-demand way, you don't really want a warehouse, you want a flow house. You want every capital asset, every piece of inventory, every person in continuous movement and optimized such that everything has continuous present utility. That's what happens in nature. That's what's happening increasingly in an on-demand world. And it's creating new ways of thinking about applying this technology to deliver that value. Now, all this is happening while the industry is dealing with what we call the triple squeeze, right? Changing customer expectations. A lot of times those expectations are actually driven by some of the dynamics I just described. Diminished predictability. As we give people more selection, then set up the expectation to deliver that faster and faster, the ability to predict what demand should be where, and we heard Tim talk about that. How do I make sure I've got the right number of croissants on Tuesday before a football game? Or I'm considering all of the dynamics at a SKU level at a given store that includes both omni, what's going to be fulfilled from online, and what's going to be fulfilled from customers coming into the store in order to better predict the inventory. And then thirdly, we're dealing with this cost and shortage of labor. So when I say changing expectations, what do I mean? Well, like never before, expectations in one setting are having profound impact on our experiences and expectations in completely different settings. And the example I use here, you might think to yourself, well, an Apple store and a visit to the doctor, what could those possibly have to do with each other? But if you think about the experience at a Genius Bar at an Apple store, before you show up, they know the serial number of your device, they know why you're there, they know what's wrong with it, they know the first several things they're going to engage you on, and you're being approached with this context, this understanding, and the whole experience is very fluid. That's becoming an expectation now that we might anticipate in completely different environments, like a healthcare environment, which probably most of us would agree is a very different experience from the Apple Genius Bar. I'm not sure why you're here. Here's a clipboard. Could you fill this out, even though you filled it out 4 times before? Wait in the room, and we'll get to you, and we'll let you know what's going to happen. So being able to bring that experience to entirely different settings is what customers and end consumers are demanding. And in fact, we're presenting later this year at a healthcare conference for a talk, and the title of that talk, not set by us at Zebra, but set by the venue providers, is the retailification of healthcare. So this whole idea that the experience that's being set in retail and understanding someone's needs can be brought into that retail environment. You think about diminished predictability, you can look at the chart on the left, but I'll talk about the one on the right here. The increase in inventory distortion since 2020 has been $2 trillion. Inventory distortion is, as the word implies, distortion. It's either overstock or understock inventory within a given location that is impacting sales. So that's a $2 trillion impact. That's roughly 10% of global retail trade. And you can see 2/3 of that is because of understocks, about 1/3 because of overstocks. So an incredibly costly problem, huge numbers, and even with all the AI and the technology and the visibility we have, the problem continues to get worse. And part of the reason is because of what I described earlier. As we chase digital precision, right, to better understand what demand is needed where, we're driving physical velocity, and that physical velocity is requiring better digital precision. So we're still working to get ahead of this, and I do think a lot of what was spoken about in terms of AI and Gen AI is going to have a pretty profound impact on tackling that problem. But it's one we're still very much dealing with, even with all of the technology that's out there. Cost and shortage of labor. So Korn Ferry estimates that by 2030, there'll be an 11% labor deficit, or roughly a shortage of 85 million workers, that will have an impact, an economic impact of an unrealized $8.5 trillion of output. So just to put that in perspective, 85 million worker shortage is roughly the population of Germany, more than the population of Germany. And $8.5 trillion is more than the GDP of Germany and Japan combined. So this is a tremendously big problem. And the only way we can address this problem is really through AI and automation. Just simply the age of the population, the number of available workers, and the economic demand is not going to allow for it to be solved any other way. And that's not about the replacement of people. It's about people working with technology to collaboratively deliver on the challenges that's before us. And you might look at this number and say, oh, Tom, that's interesting, but 2030 is 7 years away, and that's, it seems like that's too far away. We can't predict that won't happen. Well, we ended 2020 with a shortage of over 20 million workers and $2 trillion of unrealized economic output. So that's already in the books. And we're on our way, right, here in the next 18, 24 months to sort of this midpoint of that doubling to about 45 million workers and 3.8 trillion. So, there's a little bit of predicting going on here, but it is happening. We see it in the dynamics of the economy with interest rates where they are and challenges in the economy, and still really record low numbers in terms of labor. And I think any retailer would say attrition, labor availability, and labor cost are one of their biggest challenges. So when you put that all together, it's giving rise to an automation imperative powered by AI. It's just not an option other than to embrace AI and automation to deliver against these challenges of predictability, expectations, and cost and shortage of labor. So a report that was done by McKinsey actually estimates that there'll be about a 14-15% growth in global GDP due exclusively to AI. So that by 2030, there'll be about a $15 trillion contribution to global GDP from AI. And what I thought was really cool about this report is they didn't just say, well, AI, and that'll do a bunch of really cool things, and we'll end up with a $15 trillion increase in global GDP. They cited these 3 specific areas you see in the boxes. So these aren't mine or Zebra's. This is from McKinsey data that's been synthesized through a collection of economic reports. So let's look at them just one by one. Productivity gains from businesses automating processes. That would include the use of robots, autonomous vehicles. Second, productivity gains from businesses augmenting their existing labor force with AI technologies. And I think the key word here is augmented. So how can we augment the people we have? How can we replace repetitive tasks with more physical automation? Both of those things we heard Tim talk about from Sam's Club, right? I don't want to just dump more stuff on my workers because I have precious few. I want to automate the work they don't need to do and redeploy them in places that can be higher value and higher job satisfaction, frankly, for them as workers as well. And then number 3 plays into the expectation concept I mentioned earlier, increased consumer demand resulting from the availability of personalized and or higher quality AI-enhanced products and services. So that last one, what does it really do? It accelerates or exacerbates the first two, because as we get more and more personalization, we have more services, we have more value that's available to us, that's going to drive a continuous challenge on the labor side of things and expectations, which is going to require more automation and augmentation. So the way we think about that is really in 3 key areas. One is embracing physical automation to deliver that value. The second is decision automation. And the third is augmented workflows. So when we talk about AI and automation, you might hear people talk, or you might even just think more about, say, a physical robot, right? But what I want to expand our thinking on here is it's not just about physical automation, it's also about planning and tools and decision automation, so using AI to automate the actual decision process, which is giving rise to things like prompt engineering that Tim spoke about, and then ultimately being able to augment and automate workflows. So let's just take a quick tour by each of these, one by one. So physical automation, what you're seeing there in the picture on the right is a Fetch Robotics pallet mover. Fetch is a company we acquired about 2 years ago that makes autonomous mobile robots. And this one is a pallet mover, but there's ones that will move totes around for picking e-commerce orders, and it can completely autonomously navigate a physical environment like a warehouse. So instead of having a worker, in the case of picking, e-com picking, walk 15 miles a day in that warehouse as they're on their picking journey, the robot essentially does the walking or the transport, and the person is doing the picking. So the people are working in zones, and the robots are traversing the environment autonomously and rendezvousing with the right picker in order to pick those goods up and then bring them over to the packing station. So that's that type of robot that I just mentioned from a fulfillment point of view you see on the right-hand side of this chart. But I wanted to point out, even within physical automation, it doesn't have to be the robot on wheels or the humanoid robot walking around like what Musk is working on with Optimus. It can be what you see on the left-hand side, computer vision, RFID. What are autonomous ways that we can collect physical information and physical data? All right, that's really not a robot. It could be infrastructure. It could be handheld devices that allow you to count faster, essentially, using RFID. So in the picture on the left, you see that white appliance in the upper left corner of the picture on the bottom left. That's actually a RFID reader that can be mounted in a ceiling inside an environment that allows us to perpetually see every RFID tag within the area that it's covering, which might be, say, about 1,500 square feet. So if you've got apparel in that area with RFID tags, we'll see that inventory continuously. We'll have what? We'll have a system of reality of that actual inventory. Using computer vision, and I'll show a little bit of this later, but using that to not just read barcodes, but recognize product. Tim spoke about how can we reduce friction in the experience. Think about the friction in the experience when you're in the checkout lane, right? Using computer vision to be able to detect what a product is and just move you through that much quicker. Machine vision for doing sorting and fixed industrial scanners that can do anomaly or package detection. Maybe this is counting the number of items that are in a box to verify that's correct before it goes out the door. Those are all forms of physical automation because they're removing the need for somebody to go and do that highly repetitive task and allowing them to work on more valuable things as they go forward. You'll see just a couple of stats I highlighted on the bottom in terms of falling in love with the problem. If I pick up on what Tim was saying, You know, only 65% or accuracy, I should say, of inventory is only at about 65%. So if you're going to deliver in an on-demand way, and I'm going to promise you that the order you placed 2 hours ago I can ship from my store, I got to do a lot better than 65% inventory accuracy. I've got to get to 95, 98, 99% inventory accuracy. But if I can see that inventory perpetually, I can remove friction from the checkout. I can also address the problem you see in the second yellow text along the bottom, over $112 billion of industry loss due to retail crime in 2022. So what if I could use this technology to not just make a better customer experience from a checkout point of view, but I can use the perpetual visibility to ensure I have the right inventory at the right place, and on top of that, I can mitigate theft and loss because I have all of that capability within a single store environment. So hold on to the connection between those set of ideas because it's coming. And so what we've enabled with that infrastructure that I described earlier, in particular, this is applicable to RFID-oriented environments. So if you think about a fast fashion retailer like Zara or Lululemon or Inditex, all of those fast fashion retailers are deploying some form of, Uniqlo would be another one, some form of technology that looks like this. The ability to instrument the store, see the apparel in the store environment, understand what went into the dressing room, what came out, what's on the rack. If someone's leaving the store, being able to automatically tender the transaction because we can see those RFID tags move through the point of sale. And then start to do some really cool analytics like, hey, what was the dressing room conversion? Out of every item that went into the dressing room, how many of them actually made it to the point of sale? And if there's some that have really bad statistics that get into the dressing room, but they never make it to the point of sale, what do I want to do with that data and those analytics in terms of the way I merchandise and I speak with my vendors regarding challenges around that? So lots of really cool, interesting things we can do with the data. You can see here some of the statistics, zero labor required to have that inventory visibility. Again, I'm freeing those people up and I'm addressing that labor shortage. And then if there's a loss event, rather than that taking hours to catalog and get the case management done, I've got a digital breadcrumb trail of exactly what happened, and basically the case almost generates itself. You've got a digital diary of what's happening inside the store environment at every moment
You
of the
need
day. So
real-time visibility. And with
because I have the
Zebra's
audio
Smart
on this,
Lens,
that'd be
you'll have a comprehensive
better,
system
but
that
it's
gives you
about a
unprecedented
90-second
control
video
over your
on Smart
inventory,
Lens.
in-store fulfillment, and asset protection. Smart Lens is an industry-leading automated real-time inventory tracking solution that gives retailers an accurate and detailed view of all RFID-tagged merchandise in the store. It uses a family of purpose-built RFID sensors to track and record where items are and when they move, giving you 24/7 visibility of their inventory and other assets. With Smart Lens, you have the tools you need to tackle the biggest challenges facing today's retailers. Here's how it can help. Accurately manage inventory by knowing exactly what is and is not in the store. Optimize in-store fulfillment with real-time item locations and streamline pick process so you can both fulfill orders quickly and sell to the last item on the shelf. Protect your assets and get greater shrink visibility through item tracking and shrink detection tools. And because Smart Lens is a fully automated solution, it's designed to let you focus on your business, not your technology. That means less time spent with IT, counting, or compliance, and more time helping customers, filling orders, or preventing shrink. Learn how Smart Lens can help your business at zebra.com/smartlens.
So that gives you an idea of just a high overview of the kinds of value a solution that can provide, and hopefully it's clear how it links to some of the concepts I mentioned earlier in terms of system of reality, the perpetual view, and delivering systems that can operate in a streaming fashion, right, as opposed to kind of the discrete plan and then execute. So second up is decision automation. And this is being able to automate essentially a whole host of decisions off of what has a tendency to be really complicated data. Tim mentioned also a number of the things he mentioned obviously resonated with me, but symbolic analysis, right? So what he said was, hey, people that can kind of look through a massive amount of data and then kind of just see the elements that are interesting jump out at them. That's a really rare skill set. And if we can leverage generative AI, predictive analytics, machine learning, and consume that sort of information in order to highlight what are the automated decisions out of it, we can almost pre-populate a plan for, let's say, a merchandiser or a buyer, if you think about a demand planning or forecasting example. So, I already mentioned the inventory distortion problem, the magnitude of that. Omnichannel fulfillment, so many stores now are becoming fulfillment centers, so you're not just dealing with the stochastics of the physical store and who's coming in and who's coming out. You also got to deal with what am I fulfilling online from that store, and then how do I optimize my gross margin equation in real time? I mean, it might be a lot more profitable to pass on an order that's coming to a store. If I've got 4 left on hand, I know my in-store demand is likely to be 5. Do I really want to fulfill an order from that store that came in online? Because those will be fulfilled at a lower profit margin than the ones from the people that are coming in. There's a lot of dynamics that are happening there to be able to plan that right. And because of the on-demand nature, you've got to be doing this and continuously looking at it, hourly and certainly daily. All of that in the face of the lonely aisle challenge, which is the labor shortage, and then returns just complicates this even further. So buy online, return in store. Now you don't just have things being returned to the store that you sold in the store. You have things returned to the store that were maybe fulfilled from the store or might not even be carried by the store. And you've got to deal with that challenge, which is bordering on the neighborhood of $1 trillion, $800 billion in returns, about 17% of total retail sales. So as we've looked at this problem and are working on it and working with startup companies, we did a pretty exhaustive search out there of who's doing some really interesting things in this space. We ended up acquiring a company a few years ago by the name of Antuit.ai. And they coined this concept of what they call a unified demand signal. And what's a unified demand signal? Well, instead of just looking at historical data, time series data that says, well, in week 42 of last year, we sold this many of such and such a SKU, so that's a pretty good proxy for week 42 of this year, and let's start our demand plan based on that. And certainly, if anything threw that concept out the window, it was COVID, right? The idea of, in 2020, using last year's demand as an indicator of what 2020's demand would be, was definitely not a thing, and it hasn't really gotten better because we're kind of in this oscillatory period of settling down from a supply chain perspective. So what do you got to do? You got to create a unified demand signal. Not just the time series data, but what about social data, news, events, weather, local events? Tim spoke about the baked goods production and saying, hey, the AI hadn't run long enough to understand that there was a seasonality or a super granular seasonality in terms of a holiday or a particular day that would affect demand. Maybe there's even a local event that's next to that store that would drive demand. And it's impossible, no matter how good of a symbolic analyzer somebody is, to be able to deal with that amount of data and make good decisions in a continuous way, in a consistent way, is pretty much impossible. So we've got to use AI, we've got to synthesize together this unified demand signal and then have that drive better planning and forecasting. So as an example, this is a chain of stores. In this case, we're looking in California. You'll see each color on that map represents a zone that a store is fulfilling demand to. So whether they're providing that demand because of in-store shopping or they're fulfilling from that store. And so you'll see like the gray zone in Northern California is much bigger because it's less populated, but in the Bay Area or a little bit further south, you'll see the zone smaller because there's higher population density. So in this example, the unified demand signal is looking at historical data, it's looking at news, events, weather, and saying, hey, the web to store forecast for a particular SKU at a particular store might be 8. The in-store purchasing forecast is 19. It's then forecasting what returns are going to come to that store based on in-store and omni. And you'll see typically web returns are higher, right? So it's forecasting there'll be 6 returns to that store. And the BOP is the inventory at the start of the business period is 15. So at the start of that period, there's 15 in stock, which maybe we know because of RFID or the smart lens or the robot roaming around. We forecasted, the 27 in demand on the left-hand side. 6 get returned. 27 minus 6 is 21. We have 15 on hand. Therefore, the target allocation is 6, right? The difference between the 21 and the 27. But there's not enough inventory to go across all stores, and this is then optimizing across all the zip codes. So the system determines the optimal allocation is 4. Right? I mean, there's just no way you would get to this answer if you were manually trying to calculate all this. You'd say, I've got 15, I don't know, maybe I'll sell 20, I'm good, right? But as it turns out, you're going to get returns, you're going to get demand from online, and then in order to optimize the whole equation across all zip codes, the optimal amount to order is actually less than the target allocation. So finally, augmented workflows. When we talk about augmented workflows, this is probably one of the coolest areas. One of the biggest characteristics of augmented workflows is how do you reduce training, or put another way, how do you make it as simple as possible with the least amount of experience to be able to get a job done, to be able to get the workflow done, and use the device and the technology to assist the worker in doing that. So areas like augmented reality, there's great things going on around AR Core, and Google's enabling some really cool capabilities and application capabilities with AR Core, and we've now certified, we're the only enterprise company that's certified all our devices on AR Core. Mobile dimensioning, so we're using time-of-flight sensors in our products to be able to do things like produce 3D point clouds, so we don't just take a picture, but we actually have depth information along with picture information, and that can provide a lot of analysis. And then right down on the handheld device itself, we can do things like product recognition. So if you're walking across an aisle, we can recognize that product in real time. And obviously, all of this becomes really important when you think about the attrition that's occurring within retail and the overall cost and labor shortage. So what you'll see here is an example of, and I'm just advancing, but I don't think the slide's moving. But it's an example of using our handheld device, and the video should play here. Yep, you'll see on the left. So this person's walking down a freezer case. You're going to see the video in the middle is flipping on, and it's identifying the product behind that freezer case in real time, looking at facings, and then stitching all those images together in a video in order to create a digital reconstruction of that entire aisle, and then using that information to populate either stock out information or other types of tasks that should be addressed as a result. So maybe things are located in the wrong place or items are out of stock. If you compare that workflow, if I just walked down taking a video with, I don't know, what would the equivalent be? Going in and trying to scan every item, or trying to give somebody a planogram, hey, this is what it should look like, and they're trying to visually inspect and maybe check some things off. Here, the workflow is super intuitive, super fast, and it's able to provide that system of reality with a much higher frequency. Pensa, who makes that solution, is a company that we're working closely with, and that capability can run down on our devices today and is deployed within retailers. But the really cool thing about this is we can connect the left-hand side of this with the right-hand side. So if you think about using that solution to collect the inventory information, create that system of reality on the left-hand side, we can combine that with the unified demand signal and demand planning I mentioned earlier, so that, remember the 15 units that were there at the start of the business period, the actual inventory that I was saying I had on hand, that information can be gotten directly through a solution like this. And if you don't have accurate inventory in terms of what's there at the start of your business period, then the forecast is completely meaningless, right? Because you're forecasting off of a bad baseline. So it's really being able to connect these systems together to create this kind of combinatorial value. So the enterprise use cases are, really only limited by our imagination. And so this is just some examples where, we're doing things like a picking application you see in the upper left. So these are hanging AR virtual tags in space. So as somebody's holding up a mobile device, or eventually we'll get to a point of actually wearing glasses, right? Almost like an augmented reality experience. You're seeing physical reality in front of you, but then you're also seeing this information augmented within your field of view. So in the upper left, you see that picking example. In the upper right, you're seeing a sortation example. As you make your way around clockwise, we're actually putting tasks information. So that might be obvious of a DIY retailer. So this is it's highlighting whether there's incorrect prices or certain action should be taken in the aisle. On the bottom right, planogram compliance. So just holding the camera up and being able to identify where there's right product or incorrect product. And then as you make your way over to that map that's on the left, in the middle on the left-hand side, using the AR Core framework and the recognition capability that's within it, we can also do super granular locationing as well. So we can understand where somebody is in that environment, and now you're collecting the inventory information and you're tagging where somebody is physically, so you can create the planogram in real time. And this is the idea of, again, kind of putting an X through the word plan. What people are starting to call it now is a realogram, right? Because it's the reality of what that shelf looks like in real time. And the idea of a planogram goes away because it's telling you information that's too old to act on anyway. So just to have a little fun, we'll do one more video. I'll just narrate over it just to kind of how can some of these things all come together to deliver the on-demand experience, create less friction in the workflow, create better experiences overall for store associates and for customers. So at the checkout lane, you might be familiar with sort of an in-counter scanner that can read various types of barcodes. And what we've done is we've taken that type of device and we've added a color camera to it as well as a barcode optimized camera system. And we're going to be announcing at NRF coming up in here in January the ability to detect product that don't even have barcodes, like produce, as you see here, or the ability to detect a ticket switching event. So ticket switching is when someone takes a barcode off of a lower value product, puts it on a higher value product with the intention to commit a theft, essentially, and be able to detect that. And so far, we've collected over 1 million images from a large tier one retailer, not Walmart, and we've identified that they're experiencing about $400 per month per self-service checkout lane of loss because of things like ticket switching. But we can go beyond the barcode. Instead of just reading the barcode, we can use all of this camera information to collect more and more data about what's passing through the checkout lane to reduce loss, ultimately to increase customer satisfaction by checking them out more quickly. And the cool part is, just like Tesla with the 3 million vehicles they have on the road, they're using all of their cameras and the steering wheel and the pedal input to machine learn and train for full self-driving. Well, we can use the millions of images that can be collected at the checkout lane across thousands of locations and put that together into a database that doesn't allow us to just recognize those products seamlessly, but we can also stitch together reconstructions of products taken from multiple angles at the checkout lane to create 3D images. So this image was created of this product simply by taking multiple pictures at a checkout lane and then synthesizing that together into a single 3D image. Now that we've got all that information, we could go to the hands of a worker, and let's say they've got a pick list for an e-com order that one of us placed online. They can take a look at that pick list and then select down in that pick list the items that they're going to move forward and pick. And then as they approach the aisle, if this is still going, let's Looks like it may have paused. If you guys could just see if there was a pause or not. What would happen is you'd select the items off this pick list and then move into the aisle. And as you approach the aisle, you'd have that augmented reality experience. Yep, here we go. You'd have the augmented reality experience of being able to see what's on the shelf, recognize the product on the shelf, and then direct the worker directly where to pick. So unfortunately, I have to skip past that, but it would have been very similar to the augmented reality scenario you saw earlier, where I selected the items on the pick list, and then instead of trying to hunt and peck in that shelf, a hang tag literally comes up from an AR point of view and directs me exactly where to go and pick. So think about that. No training, essentially, for the worker, because it's right there, the work instruction's right there in front of you in real time, and the opportunity, the chance to pick the wrong thing is greatly mitigated. And you're delivering a better experience to that worker as well. So, we really believe at Zebra, and I think it's going to be pretty evident in the event here over the next couple of days, that automation, AI, but in particular physical automation, decision automation, and augmented workflows are going to continue to push value ever closer to the point of demand in time and space. And if you're investing, if you're thinking, if you're learning for the students in the front, and you're thinking about what are new ways that you can create value in the world, I would say you can't go wrong if you're focused on delivering that value ever closer to the point of demand, and think about what technologies you can learn more about, you can trial, you can fail fast on inside your organization to do that, and ultimately you'll win. So looking forward to speaking with many of you over the next couple of days and collaborating on these areas, these technologies, and just making the world a better place. Thank you.